Is this section relatively short?
All right, so this is 3.5. There is only one learning objective versus the marathon, I think we had 6 and 3.2. Tons. So we're doing inequalities involving quadratic functions. Our learning objective for 3.5 is to solve inequalities involving a quadratic function. Yay! So we are replacing the equal sign in our quadratic with an unequal sign. Less than, greater than, less than or equal to, or greater than or equal to. All right, so we're going to solve x squared plus 5x plus 4 greater than 0 and graph the solution set. So the first thing we do is graph our function, and this is a quadratic. It has a positive a value in our ax squared plus bx plus c. We can factor it into x plus 1 and x plus 4, so I know that my intercepts are at -1 and -4. And that the y-intercept is at 4. So if you plot those points on a graph, vertex 2. So if we use our vertex formula, which we use the heck out of in 3.3, our vertex is at -b over 2a. In this case, b is 5, a is 1. So -5 over 2 times 1 is -5/2. And then the y-coordinate for the vertex is what we get when we plug in -5/2 to x squared plus 5x plus 4. So we do the math on that and we get -9/4. If you don't know how to do this fraction math, make sure you put a star next to this and ask me later, because this is a skill that we gotta figure out for y'all. All right, so our vertex is at -5/2, which is -2.5, and comma -9/4, which is 2.25. So when you graph that, you put all those points on your graph and you get the shape of your inequality. So now, we want everything that is greater than, where is the function greater than 0? That's what we're asking. We want this function, all the function values greater than 0. So that is starting at -4 and -1. Everything of that. There it is in red. So at -4 and -1. Now we have to put a little hole at -4 and -1 on the x-axis because we are not greater than or equal to, we are greater than 0. So shade this upper part, these 2 legs of your parabola, a little bit darker, and make sure I can see the hole at -4 and -1. Yes. So our function, yes, look what happened, it just popped over. Perfect. Exactly. So our function is greater than 0 from -infinity comma to -4, and we do a parenthesis and not a bracket because -4 is not included, or from -1 to infinity, and -1 is not included, so it gets a parenthesis.
It's to negative infinity? Isn't it just like...
So this leg will go off forever and from all the way to negative infinity. It'll keep getting more and more negative. So we say negative infinity to -4, then we pick up the next one, or -1 all the way to infinity. So you go left to right when you're doing your interval notation.
So like you put negative infinity before -4 when you... Because it like comes before, since it's like going this way. It, like,
So you always, yeah, so always like we read from left to right.
Okay.
So always list left to right. Even if I'm going, oh, this graph starts at -4 and goes to the left, oh, we want to read your interval left to right.
You said 4, but I put the U like the and. Is it the
And is the rainbow, or is the U shape?
Okay. Well, why is it or not?
Because either one of those is a solution.
Well, why
So I could, because you could, if I was over here in -4 to negative infinity land, then that's a good solution, as well as, or anything over here. I don't need to have one in both areas to be a solution. Okay, so we make a little number line, and we're going to graph this these intervals on our number line. So we are all the numbers that are -4 to infinity, or negative infinity, and all the numbers that are -1 to positive infinity. It's not a number line. It's the number line. There's a -4, and it shoots off to the left to negative infinity, and there's a -1, and it shoots off to the right to
So
positive.
you can put like a parenthesis or an open circle. It's just like
So I'm not sure if this is actually the first time I've seen them do that.
okay, because
I would do open circle. Like, if I'm graphing this, like, not using the book created. But it's good. It's good that we see different ways to do it. Hold on. All right. So we're going to do that again. But this time we're going to solve the inequality x squared less than or equal to x plus 6 and graph the solution set. The first way we can attack this is to rearrange our inequality so that everything is on one side of the equation, the inequality, and everything else is, and the other side is 0. And I like 0 on the right because it keeps my squared term positive. So you can subtract x and subtract 6 from both sides. And then we have a situation very similar to the one from before. In order to graph this, we know we have a y-intercept at -6. We know that if we factor, we get x minus 3 and x plus 2, so we have an x-intercept at 3 and -2. And then if we find our vertex by going negative b over 2a, so b is -1 and a is 1, so it would be -1 over 2 times 1, which is 1/2. We plug that in to our x squared minus x minus 6 to get our y value for our vertex, as negative 25/4, and I believe that was 4 point. It's in the 4 range, the negative 4 range.
It's like 6.25.
4 goes into 24 6 times with 1 left over, yeah. So 6.25. And if we put all those points on our graph, it kind of looks a little something. And then we want all the values that are smaller than or equal to 0. So on our graph, that starts at this negative 2 and loops down and goes all the way to 3. So we can use one interval to describe the solutions here, which is bracket negative 2, comma, to 3 bracket. So negative 2 to 3 included. And then we graph that on the number line. If you get real close to my screen, you could totally see. And this is where I would use a closed circle, but they use the bracket symbol. So it's brackets at negative 2 and bracket at 3 and everything highlighted in between. And that's the solution set. So I've really got 2 more to go. 2 more slides. All right. Method number 2. We can treat each side of the inequality individually. So if we say our left-hand side is f of x and our right-hand side is g of x, we want to find where f of x is less than or equal to g of x. So we then graph both functions. So our blue graph is going to be x squared, and our green graph is going to be x plus 6. If you are a blue-green colorblind, my apologies. The squared is going to be the U-shaped, and the x plus 6 is going to be the line. All right, so we know how to graph y equals x squared because that's our parent function for our quadratic. And we know how to graph x plus 6 because that's our linear function. We did a whole doggone chapter on that. So we graph the two, and we want to find where x squared is less than our x plus 6. So we look at this point, and we look at this point, where they're equal.
So if you're graphing like a linear function, which is x plus 6, you just put it on 6 and it's just a straight line.
Yeah, up 1 over 1 is our slope. Throw that line down. Now, unfortunately, there's no other way. So if we're interested in where our function is, our two functions are equal, we're still kind of solving that quadratic equation and factoring and finding the x's. So this is the same as we had to do before. So if you're looking for a method that is less work, it's kind of the same amount, but you want to stick to the one that makes your heart happy or doesn't give you a heart attack. We'll go the opposite side of that. Okay, so from before, we know that x is equal to 3 or negative 2 is where our functions are equal. And when we plug in 3 to our f function, we get 9. And when we plug in negative 2 into our f function, we get 4. So these coordinates are -2, 4, and 3, 9. So let's go back to the original question. Where is f of x, for the blue one, less than or equal to g of x, which this is a green one? And that happens between -2 and 3. So here we are again. The interval is -2, 3. We graph that on a number line, just like we did before, using brackets. It's everything included in between -2 and 3. Okay. Last one. One more. We got this. We're going to solve the inequality -2x squared plus 8x minus 9 less than 0 and graph the solution set. So we're going to look at our function -2x squared plus 8x minus 9. I know that graph is going to be my yoga people, a downward facing dog. So if he is a parabola, that is sad frowny face. The vertex, if B is 8 and A is -2, and we plug that in, we get -8 over 2 times -2, negative and negative, positive. 8 divided by 4 is 2. We plug that in up here to get our y-coordinate of our vertex, and we get 2 squared is 4, times -2 is -8, plus 8 times 2, which is 16. -8 plus 16 is 8, and 8 minus 9 is -1. So our vertex is at 2, -1. Well, that's an easy guy. We know he's facing down. We plug in 0 to get a y-intercept of -9. So the vertex is there. We look at our y-intercept. We know that we have symmetry at x equals 2, so we can put the coordinate on the other side at 4, 9, and we have the shape of our parabola. So the original question is asking, when is this graph less than 0? I'm going to give a pause, and I want you to think about, where is this graph less than 0 numbers? So because our graph, 100% of our graph is below the x-axis, no value that we put in for x will ever give us a positive when we're dealing with this function. We can say that the function is always less than 0 and the solution side is all real numbers, or in interval notation, that's parenthesis, -infinity, comma, infinity, close parenthesis. And on the number line is just the number line. Booyah. So if you have to graph, it's just the graph of the number line. Everything. And that's it for today, folks.